Yeah, thanks, Rich. Um, so today's presentation's on solar panels, basically. Um, Solar PV for electricity or solar thermal for hot water. Basically, we've had a lot of developments recently we've been working on, been multi-story developments where the roof space is constrained and we have to make sort of decisions over whether to use one technology or the other technology or just try and use both of them, which one's going to deliver the best carbon savings. I suppose it could also be relevant for just like standard single detached dwellings if you're budget constrained and you're thinking about it, you've just got £2,000 or whatever to spend or one or the other, then you also want to know which one's going to deliver the best sort of environmental benefits. So that's what we'll try and kind of cover today. So I'll start off just by explaining the technologies, what the differences are between them in terms of design and what they do. And then I'll run a couple of scenarios looking at a few different options for heating and solar PV and seeing which one comes out best environmentally and look a little bit at costs as well. And then, yeah, if there's anything else we can think of that might also work, I'll try and cover some of those other options. So to start off with solar thermal is basically just a panel of pipes that sits on your roof and you run cold water through the pipes, the sun heats it up during the day, you store that in a tank and use it whenever you want during the day. Yeah, fairly simple in principle. There are two types of solar thermal panel. This is your kind of standard cheaper version. It's a copper pipe running along a thing of insulation. It's painted black to absorb as much radiation as possible. Yeah, it's pretty basic. And then you get onto evacuated tubes, which are a bit more expensive, but they're a bit more efficient as well at capturing that sun's radiation. The flat plate panel, I think, captures about 40% of the radiation and turns it into hot water, and evacuated tubes are around about 55. The other main difference between them is the flat plate works very well when the sun's shining directly onto it at right angles, but in the morning or in the evening, the sun's radiation is being reflected off some of it. It's not absorbing as much as the tubes, which are circular, and it doesn't matter what angle the sun's shining at, they're still capturing most of its radiation. PV, I'm not going to go into the physics behind how it all works. Effectively, you've got sun shining on a bit of silicon and makes electrons move around, and they are running in a DC current. You run it through an inverter and you can use it in your home. If you don't need to use it in your home, you'll be exporting it to the grid or storing it in a battery. Batteries at the moment aren't really commercially viable in residential setups. So whenever you're generating more electricity than you're using in your house, you need to export it. As solar thermal, you're sort of storing that energy in a tank that you can use later on. Yeah, this is the kind of standard profile, residential profile. So you've got kind of base load coming along all day long, which is your fridges and everything that's sort of on standby, and then this is your morning sort of peak when you're making breakfast and stuff, and coming home in the evening and switching everything on. So a solar PV panel is going to be generating in the morning and sort of peaking in midday and coming down again in the evening. Anytime it's generating more than you're using, then it has to be exported. Yeah, so this is a solar system, and this system's sized to offset all the energy that's being used, the electricity that's being consumed in the night time when the solar PV is not generated. So you can see there's quite a lot there that you're not actually using in the house, going straight mixed back into the grid. That's the sort of main differences that I picked up from the two systems in relation to this. These are the three sort of scenarios that I thought I'd test. I've got a PV system which is about the same, the pictures don't show, but the test that I did is using the same area of PV as solar thermal. I've taken a standard gas instantaneous boiler, which uses gas. There's a heat pump, which is a lot more efficient and uses electricity instead of gas. And then there's our solar system. In this case, it was generating about 70% of the hot water requirements for a normal 240 litre tank.
Sorry, back when you have efficiency there, is that like 85% efficiency? That's the gas, the conversion of the gas energy into hot water of that.
Yeah.
Okay, and then the heat pump's 270.
Yeah.
So yeah. Okay.
Yeah. So yeah, you're losing 15%, but yeah, on the heat pump you only need a third as much sort of thing as you're using. So I plugged those scenarios into eTool. This is a kind of screenshot of eTool. And you can already start to see a little bit what's going on. You've got a high demand. This is the standard gas hot water solution, heat pump, and solar. You can see that the gas is using a lot more energy. Interestingly, the heat pump is coming out quite high on the carbon side, but we'll also have the PV, which might be offsetting that. I'm not sure, so I put them all into a little graph, and these are the results. So this is a standard sort of base case with no PV and no solar, nothing. This is the gas instant boiler with half a kilowatt of PV. This is the heat pump with half a kilowatt of PV, and this is the solar thermal system with no PV. So it's looking like at the moment solar's pretty good. I was quite surprised at how bad the heat pump actually came out. It's only just better than the system without any PV on it at all.
Is that that's using the National Energy Market carbon intensity, the default carbon intensity for? So I guess that should be probably clarified. Is this is the eastern states energy carbon intensity for electricity? So which is what the heat pump's relying on, and it's probably one of the worst carbon intensity grids in the world. So it's more than double what, say, the UK carbon intensity of their grid is. So the same system work, or the same comparison in the UK, although the solar component would drop off because it's not as hot, just by moving the grids, all else being equal, that heat pump would halve in impact. So it would go from not looking so good to looking quite a bit better. And
yeah, what that peak really shows is how bad the grid here is. Because you've got a system that's 3 times as efficient as the gas, but the grid's so bad it's coming out marginal improvement. Then I looked at the operating cost. Annual operating cost, and it came out quite surprising. So heat pump's actually really good when you look at it in terms of how much you're paying for your energy, which to me kind of says that the grid's a bit too cheap because it's doing all that polluting. but you're still paying sort of same similar amount in operation on as you are to renewable sort of source. Yeah, the gas one's a little bit better. That's just purely from the 0.5 kilowatt of PV that you've got on, and yeah, the solar power is similar to the heat pump. Then this is a sort of balance between how much you're paying and how much carbon you're saving. So it's a cost per tonne of carbon that's saved. I thought, oh, well, this is really cheap, but you're not really saving much carbon at all. So the cost per tonne of carbon is still very high. Cost per tonne of carbon for solar is, yeah, still very low. And then a little look at the operating costs. So I assumed this was $1,000 for a sort of standard boiler. You had $600 for the PV in these two scenarios. The heat pump's probably about $1,000 as well. And my solar system was $3,000. And the sort of simple payback on all of those, again, the heat pump comes in very low because you're not spending much more money, you're getting a little bit of saving. The solar thermal system, you've got 5 years. They're all still very low sort of payback systems. Yeah, it's just interesting sort of differences between money that you're paying out and the carbon that you're saving. Doesn't always correlate. The cheaper system might not necessarily save you the same amount of carbon. So then I was like, oh, what happens if you just cover the whole roof in solar thermal, since it's got such good sort of carbon savings on that initial scenario. So this was the scenario I had at first, which is 2 meters squared of solar. You double that to 4, it's still beating the PV, which is just a direct drop in carbon emissions. You double the amount of PV you put on the roof, you double your carbon savings. Double amount of solar, you start to level off a bit. So yeah,
that's because you capture it, or there's a limitation for the amount of heat that you can store with the hot water. Is that right?
So this assumption is still just a 240 litre tank.
Yeah.
So yeah, you are limited there. You could double your tank size to sort of 500 litre, and it drop. Yeah, it would look a bit like that.
Yeah.
But if you're modelling a house, there's a limit to how much hot water you use as well. Yeah.
Yeah,
so
true. You can't. Yeah, not in this country. You can't export your hot water to the grid. In Denmark and some places with communal heating systems that pump heat around the whole city.
Yeah.
Then something like that might be possible, but yeah, not something too interested in this country. But yeah, you can get systems that have just massive tanks and a lot of solar, and they supply your hot water and your heating all year round, sort of things. Just store all that energy. But yeah, in this sort of standard scenario, you get that drop off.
Yep. And a 4 square metre, that's about a normal solar hot water system for a residential building. Is that two
double panel?
Two double panels, roughly?
Yeah, it's just under. I'd say it's more 3.5. Yeah, 3.5.
Yeah, around that. And that sort of matches really well, doesn't it? You get a decent sized solar hot water system.
Yeah.
And then
Means they're designing them.
I just cut. I'll let you do the conclusion because I think that's probably what you'll address.
Yeah, so that's your sort of ideal solution where you've got room for both technologies. This is your sort of optimum sized solar system, and then filling the rest of the roof space up with some PV to offset your electricity. Not sure where this one is. I would think about putting the solar thermal on the west side of the roof, so it's capturing more energy throughout the day and sending it into the tank that you're likely to use in the evening, whereas on the east side, capture it in the morning and then it'll just be sitting in a tank losing heat.
Who voted on that one?
I think
the contractors stuffed that one up. can
No,
tell.
I'd say
Might be
that,
the other way. It might
Oh, well, it could be like a
PV
tree
might
or
be
a roof
facing west.
the other side.
It is. The people that I know it's a mate of mine's house, and
Oh, is
I
it?
was actually helping him with it. And we marked on the plans where the hot water and the solar PV were supposed to go,
And they didn't
and
end up there.
the solar hot water guy just found the easiest bit of roof that he could fit it on that gave him the quickest and easiest install. And
So
just
which way
laid
did
it
you
up.
face?
So the solar hot water is facing north, and the PV is facing west.
Ah, yeah, okay.
Yeah, you could
Yeah.
almost pick the shadow. I mean, that's a midday, you know, on probably this time of the year. You can pick the shadow going down into the thing. So yeah, look, it was an idea.
Where did you say? You said.
There's in Bayswater.
Where did you say put the solar hot water on the west?
Solar hot water on the west, yeah.
Yeah, like, it looks like there's some more panels back here.
It was actually going to be mixed, so it's a inverter that has two maximum power point trackers. So we're going to split the array, try and get as much solar on the north as we could, and then split the other array on the west with the solar PV.
But, so the smaller parts would have been on this roof where the hot water.
Yeah, it would have been almost 50-50. You get that. It's the best laid plans of mice and men, I guess. Yeah.
And then there's some more extravagant solutions if you do run out of roof space.
Wow.
The solar thermal panels can go on the wall, especially west-facing wall, and you've got the evacuated tube types. They're not going to lose too much energy because they're, I guess, absorbing more as the sun moves through the sky. You can get really large ones. This one, the solar thermal is actually built into the wall, constructed into the wall, so it probably gives you some thermal performance as well as hot water. This, I think, is PV actually, PV glass, some sort of magic paint over the glass. I'm not sure how efficient the PV would be, but sort of a kind of 20 years from now, we could just be painting it all onto our walls and wherever we've got free anyway.
Seth Hogg sent me or gave me he heard something on the radio the other day, and that they're patented some of this technology out of Edith Cowan University, I think, here in WA, and I think it's only at this stage 20 watts rated capacity per metre squared, but it's coming. It's interesting.
You get better performance if you put trackers on. So would you consider putting trackers on where you put limited roof space to improve the performance of the panel?
It's in trackers in tracking the sun.
Yeah.
It's pretty tricky to justify the cost of trackers these days.
Okay.
One, because panels are so cheap. So if you got the area to throw more panels up, but if you're really stuck for roof space, it's still a challenge on a residential roof to justify the additional cost of putting a tracking mechanism up for such a small system. It's like even on the really big commercial systems, there seems to be there isn't a general consensus yet as to whether you bother putting trackers up, and the cheaper the panels are getting, the less likely it is, even in a commercial solar farm, that they bother putting trackers in. They just put more solar panels. So it's there's things that people do, like clever things that if you can build it into like a solar pergola or whatever, that you manually go and adjust every now and again to get a bit out of it. But
You still need the space for shading as well,
Yeah,
like even if you've got
you're
trackers, they still need to be spaced out. Whereas a flat panel, you can fit twice as many actually on the roof, so you lose a few percent efficiency.
You've shown the panels there flat on but by normal elevations, we want to put shading on windows anyway.
Yeah.
Angled shading. So, could you consider perhaps putting them out as actually shading devices over the windows all the way down?
I don't know why we don't see more of it, because you go to like commercial buildings and they spend squillions of dollars
On
on fancy louvers and facades. Aluminium, and I bet you we can do it cheaper with solar PV. Because solar PV is so cheap. It's cyclone rated, it's hail resistance, it's corrosion resistance, it's got the whole lot, but are there any architects in the room? They don't like it because it doesn't really, they don't get to do the thing that they like. I think that's part of it. It's too much of an engineered solution as opposed to a classic design solution. If we got to design the buildings, you'd probably see a lot more solar PV on the facade.
It's just a design solution.
Yeah. Yeah.
Yeah, they talk about the Eve thing in residential.
Yeah.
But the Eve thing actually is the whole length of the wall.
Yeah.
And you actually only want shading on the window plus some element by the side to allow for that horizon set across the sky.
Yeah.
So, you can turn the panels around. There's an issue about which way the panels are. So,
No.
so you just use it horizontally across the top of the window. And
There you go.
it's done 2 jobs in one.
That's about all I had to say. I found this up. So this was a nice big giant solar system just in front of the Petronas Towers in Kuala Lumpur, and it's facing south, which is okay, but they just started building this huge tower going above, essentially shading that PV for the whole half day, and yeah, I don't know what happened, but they shouldn't be allowed to do that, or if they are, I don't know what the solution is. Obviously this is a massive multi-billion sort of dollar tower, and if people have the kind of right to their sunlight on their roof, I don't know.
Built by the other side of the mirror.
I was going to say,
Yeah.
they should be forced to build a solar farm out in the I don't really know Kuala
Sure,
Lumpur.
yeah, well, but
if there's a bunch of factories that multi-million-dollar building financing, that should be forced to fill them up with solar PVs and offset it.
Yeah, that would offset the carbon, but it's still taking away the sort of carbon neutrality or whatever that that building was claiming.
So in conclusion, is it generally in, say, a residential sense better to get, if you've got limited roof space, start with solar hot water and then fill up the rest with solar PV? Is that what a conclusion you can draw from that?
Yeah, if you've got gas, yeah.
So if you've got gas, you go solar hot water with a gas boost, fill up with solar PV. If you didn't have gas, so you had solar hot water and an electric boost, would it be a similar kind of result, do you think?
Yeah, it would be similar. It wouldn't. Yeah, it's something I should have tested actually, but it would be similar. But yeah, it wouldn't be as
impressive.
Yeah.
Okay.
Is there an issue about the number of collectors? I mean, if you've got more collectors on your solar thermal, does that get the temperature up sufficiently so that you can then eliminate the boost?
Well, yeah, I think
The boost is for the peak. So when you're in winter days, when you
I just sold a house and had 3 solar thermal, just hot water, but I had 3 panels because it was facing east because of west. I only had west and east because it was still in road. And I basically, it was electric boosted, but I just turned the electric on in the winter time for 2 or 3 months in the winter. And it worked fine. It was just because I'd rather do the gas, which was like $2,000 more, or whatever it was, to pump the gas into it. It just,
I've got a 2-panel electric, recently, and there's 4 of us, 2 kids, 2 adults, and we're just about getting by. We're not feeding anything else, only not feeding washing machines or dishwashers, but normal showering and household use.
Without anything like the modelling. I think the modelling that Pat would have done, correct me if I'm wrong, is sort of based on average household consumption. So while you and me probably would get away with it, if you're the average family in who wants to do hot washes all the time and have 3-minute showers, then you start to see a trend towards what Pat was showing there of requiring a little bit more than just 2 panels. But then you sort of hit a point, didn't you, where it's like, hang on, that's enough solar thermal, it's time to go solar hot water, and that was a nice little trend, I thought. So I'm just trying to think,
There's a few other things as well that in the high rise that start to I guess affect things is you'll generally not have as much storage space, which may affect the amount of value you get out of the solar thermal panels. And the other thing is you have to continually circulate the hot water as well, so that the person in unit 1 down the bottom doesn't have to wait 10 minutes to get a shower to get
So then you lose the benefit.
Well, you lose heat as you're circulating, and I guess those things just muddy the waters a little bit with this, don't they, Pat? And it's not.
Yeah, a little bit. You have to test every single development
I was
basically.
trying to get a nice blanket rule there.
Yeah, unfortunately, it's
Well, probably a single residential.
You single residential, you can say, go solar hot water with a gas boost, and then go solar PV, but and then, so how do I justify my bloody heat pump?
It's cheaper.
It's cheaper, so I had more money left over to spend on.
It's not cheaper than an instantaneous gas.
No.
you didn't have to fight
Like
the
the strata.
strata again to get the other panels on.
I was in strata and I had to pick my battle. It was solar hot water. I wanted solar hot water and solar PV, and I got my solar PV, but it was a bit of a challenge. I guess the other impact there too, though, was the price difference. I mean, you obviously had to pick some generic prices of the various technologies. So being in a 2-storey building to get a solar hot water system on a 2-storey roof, added $1,200 or something stupid to the cost of doing it. So again, you can't just have a blanket rule. But if it's a single-storey detached house, no strata issues, solar hot water, solar PV.
Yeah.
But every other one needs a bit of a case study.
Is solar
That's cool.
panels still that if you have shadow on it, that the whole thing doesn't work?
Not really. There's different types of solar panels, but even sort of your bulk standard solar panel will tolerate a bit of shade. And what people get worried about is it isn't proportional to the amount of shade. So if you get one panel with 10% shading, you can knock out 30% of that panel, which might knock out 30% of the entire system. So it's not linearly related, but it's not. Some people get fear tactic, which is if you get any shade, the whole thing doesn't work, and that's.
Because that's what they told me a couple of years ago.
Right,
He had
definitely.
bleached trees and I heard his house, so he
Yeah.
couldn't do it.
It's definitely not the case that a little bit of shade will take it all out, but you want to do a fairly comprehensive shade analysis.
Yeah, build a shed.
Build a shed, there you go. That's the answer.
We got a lot of solar thermal is really mature.
Yeah.
Solar PV is less mature, but we see developments coming all the time in solar PV, and I'm sort of resist going and paying what they paid 5 years ago or 3 years ago. And I can see now hear that the new panels coming out are going to be twice as efficient. So, at what point, because there's still the movement in performance efficiency in solar PV, is there an argument which says put the money into solar thermal because the developments in that are likely to be less? So if you're putting money in now, put it in solar thermal and then buy time on the solar
If
PV.
you're purely doing it from a dollar perspective, and I'm not very good with finances, but a good accountant will tell you to play the cards you have today. So if you can make money out of investing in something today, that's where you invest your money. Do your lost opportunity cost with a predicted yes that the price of solar PV might drop by this amount, but play what you got today, because if people are telling you that panels are going to halve in price, probably one of the people that are trying to get funding for a new solar panel that they're producing. And if you look at the technology learning curve of solar PV, it's never just gone drop by half. It's doing a really nice curve. There's been a few dips where you got things like they ran out of recycled silicon, so they started producing bulk raw silicon for the solar PV market, and we saw a pretty rapid drop. But then it does that again, and you'll see little dips. But look, we'd love to be proved wrong, but very rarely do you see in the technology. And you say it's not mature, but solar PV has been around since the 40s and 50s. They're making commercially available panels. So, and since then it's done this. So the likelihood of something happening tomorrow where it just halves, I think, is pretty unlikely. And generally, when you hear those stories or you read them in a newspaper or on a blog post, it's, if you look deep behind it, it's generally someone chasing a research grant or a funding grant in order to pay for their new, paint on dye or something like that. So, because I used to sell the stuff, and people would always say that. It's like, well, look, you can, if it's good today, do it. Why not? Why hang on to if it's better than money in the bank, if it's better than money in your mortgage, do it. And if you make money out of it, do it again. And if it gets cheaper, do it again. That's the way I look at it.
If it's a financial decision.
Yeah.
The other thing, there are risks with waiting as well. So a large percentage of the system price drop in Australia has been due to the exchange rate.
Yeah, Australian dollar.
So our exchange rate's gone from probably 65, cents US, the Australian dollar up to over $1. So you've nearly halved your cost of PV to an Australian due to just exchange rate, and so I don't know. Some people probably argue that the exchange rate's going to stay where it is, or even go, the Aussie dollar will get stronger or whatever. But I've got no idea about that. But I know the long-term trends probably suggest that it will probably drop back down a bit. In which case you might lose 2 years worth of price gains overnight. So it's sort of
that the impact of the price of the solar panel and the technology is become less and less. Like when I put my first solar PV system in, 85% of the cost was wrapped up in the solar panels alone, because it was $10 a watt. You're now paying $1 a watt for solar PV. So if you look at the cost of putting in a system on a roof, you've got solar panels, inverter, aluminium rails and racking, cables, conduit, sales guys, business overheads, installation labour. So the panel cost as a component of that is way less than it used to be. So even if it halved overnight, which I very much doubt, but even if it did, you'll say all that it's going to be the same. I mean, the installation cost is something that might shift as the Australian economy kind of, rationalises and electricians start getting paid something like what an engineer gets paid or something like that. You'll probably find that you can get an install a lot cheaper.
It's also the quality should improve. I don't know. They're saying now the last 25 years and after 10 years there's only 80%.
Yeah, look, that's another interesting one, because they have very strict rules on what solar panels you can import, and they all must meet that 25 and 10-year warranty. So 25 years they must still be producing 80%, and at 10 at 10 it's 80, and they've got to last until 25. But the reason they had that was to ensure that you didn't get bad quality panels and give the entire solar PV industry a bad name.